Here we have to solve for x in the given exponential equation. Okay, so when I look at the given equation carefully, here I have 3 to the x power, here I have 9 to the x power, but 9 is a power of 3, so that is 9 can be written as 3 square. So when I write 9 as 3 square, I'll be able to write this term in terms of 3 to the x power. So once I get this term in terms of 3 to the x power, so I'll have the complete equation in the term 3 to the x power. So 3 to the x power can be replaced by some new variable and I can solve for x. Okay, so in my first step, what I'm going to do is I'm going to write this 9 as 3 square. So 3 square, and for 9 I have written 3 square, and we have x, the exponent for 9. The same exponent can be taken over here. So 7 times 3 to the x power positive 18. Okay, now let's consider the power of a power rule in exponent. That is, let's consider base a and consider exponent m for the base a. And for this complete a to the mth power, we can consider the exponent n. Okay, whenever we have two exponents like this, what we can do is either we can multiply these two exponents or we have to switch these two exponents. Okay, I'm going to switch these two exponents, then I'll be getting a to the nth power whole to the mth power. Actually, this is a power of a power rule in exponent. Okay, the same thing we have over here. We have base 3 and we have exponent 2, and for this complete stuff we have exponent x. So now what we can do is we can multiply these two exponents, otherwise we can switch the two exponents. So I'm going to switch the two exponents over here. So when I do so, I'll be getting 3 to the x power whole square equals to 7 times 3 to the x power positive 18. Okay, here I have 3 to the x power, here I have 3 to the x power. So now I'm going to assign a new variable for this 3 to the x power to make the solving process easier. So let me assume y equals to 3 to the x power. So wherever we find 3 to the x power, we can plug in y for that, because we have assumed y equals to 3 to the x power. So this 3 to the x power can be replaced by y, and we have exponent 2 over here, so it will become y square 7 times. We can plug in y for this 3 to the x power, then it will become 7y positive 18. Okay, now we have a quadratic equation in the variable y, but we have to get this quadratic equation in standard form so that we can solve for it easily. So that is the standard form of quadratic equation is ax square positive bx positive c equals to 0. That is, we must have everything on the left side, we must have 0 on the right side. But here we don't have 0 on the right side in this quadratic equation. We have 7y positive 18. So I have to get out this 7y and positive 18 to get 0 on the right side. Okay, for that I subtract 7y from both sides, and I subtract 18 from both sides. So when I do so, this positive 7y, negative 7y will cancel out, positive 18, negative 18 will cancel out. I get y square, then negative 7y, negative 18 on the left side. On the right side, we have nothing, so I have to write 0. Now this quadratic equation is in standard form because we have everything on the left side, we have 0 on the right side. So what is the coefficient of y square over here? So there is coefficient 1 for y square. So I think we can solve this quadratic equation by factoring. So whenever there is a coefficient of y square is 1, we have to consider the constant term in the quadratic equation. So now I have to get two factors for this constant term, so that the product of the two factors equals to negative 18, and the sum of the two factors equals to the coefficient of y, that is negative 7. So I think negative 9 positive 2 will work. So when I multiply negative 9 and positive 2, it's negative 18. When I combine them, that is when I add them, I'm getting negative 7, so which is the coefficient of y. Okay, now to get two values for y, because it's a quadratic equation, the variable y, so we'll be getting two values for y. Okay, to get two values for y, I just need to do a simple work with these two factors. That is, I have to change the sign of each factor. So already it's negative 9. To get the first value of y, I have to change this negative 9 to positive 9. So the first value of y is positive 9. And to get the second value of y, what I need to do is I have to change the sign of the second factor, that is positive 2. So if I change the sign positive, then I'll be getting negative 2 as the value, second value for y. Okay, y is the variable taken by us, so it has to be replaced by the original stuff 3 to the x power. So then what do we get over here? So we get 3 to the x power equals to 9, and or 3 to the x power equals to negative 2 over here. So I just plugged in 3 to the x power for y in each of these two equations. Okay, now I have to solve for x in this equation. Actually, we have the variable x at the exponent. Okay, whenever we have variable at the exponent and we have to solve for it, what we need to do is we have to get the same base on both sides. Here the base is 3. On the right side we have 9. It is a power of 3. So 9 can be written as 3 square. So 3 to the x power equals to 3 square. Okay, now these two terms are equal with the same base 3. So whenever two terms are equal with the same base, what we can do is we can equate the exponents, then we'll be getting x equals to 2. Okay, now from this equation, the first equation I got x equals to 2. Okay, now let's go to the second equation. Here we have 3 to the x power equals to negative 2. Okay, here the value of 3 to the x power equals to a negative value. So whatever real value we consider for x over here, for example, if I consider 3 to the first power or 3 to the second power or 3 to the third power, just I consider a positive value for x. So 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27. So when I consider a positive value for x, always its value is a positive. Okay, what if I take x equals to 0? 3 to the 0th power means it's 1. Even now we get a positive value. Okay, what if I consider a negative value for x? For example, 3 to the negative first power, it will become 1 over 3, but still it is positive. 3 to the negative second power, it will be 1 over 3 square, which becomes 1 over 9, still it is positive. So, whatever real value we take for x, whether we take a negative value or positive value or 0. So, always the value of 3 to the x power is positive, but here we get negative value on the right side. So, this is false. So we can ignore the second equation because it's a false statement. So for the given equation, the value of x is 2.